Heinemann Higher. Chapter 6 in Differentiation, mixed exercise 6S, the last question, number 23, a previous higher question from 1989. Now, again, the description's all there. There's a new warehouse. It's in the shape of a cuboid, so that's that box at the bottom. It's supported by 3 identical parabolic girders, spaced 30 metres apart, so at least it's got a fixed length. And it says the shape of each girder follows this equation: y equals 9 minus a quarter x squared. Given that AB is 2x metres long, show that the shaded area, that's this area in here, the shaded area at the end of it is given by this expression. And then the second part, as before, optimise that. Right, so the first part's algebraic. How can you arrive at the area of that rectangle? Well, the area of a rectangle is length times breadth. And handily, even if I hadn't said that, you'd have had to give that a length, and since it's symmetrical, you'd probably have called that anything you liked. A, B, why not just call it x? That's all they've done. So they're saying that distance there is x, which means that calling that distance y means I can get y in terms of x, because it lies on this parabola, and if the x coordinate is x, the y coordinate is just that expression. So the first part would be this: that area is going to be given by, since x makes up only half of it, the area is going to be 2xy. So it's going to be 2x times whatever y is, and y is this expression, so it's 2x times 9 minus a quarter x squared. So that's simply 2 9s are 18x, and that'll be a half of x cubed, and that's it just in terms of x now. So that was it, that's all there was to the first part. Not a lot to it at all. Just create the name for one part, and the other part is tied to it by that formula. And that was part A. Part B, optimise it. What's the maximum? What's the maximum volume you could get then? Well, so what should you choose for x to make it the maximum volume? Will you make it thin so it's really tall, or wide so it's really short, or will it end up squarish, or so on? You will find out by doing this. Differentiate it. So that's just going to be 18 minus, and with that being a 3, it's going to be 3 upon 2x squared. And you'll have an optimum value. So same as before, just like turning points, you'll have all its values, talking about expressions here, functions. You'll have an optimum value if that derivative is ever equal to 0, because otherwise it just keeps increasing or decreasing forever. It needs to take a turn somewhere to have an optimum. So that means I've got 18 minus 3 upon 2x squared has to be equal to 0. Don't need to do any factorisation here. Only one mention of the variable, you can just solve it linearly. So that means that 3 upon 2x squared would be 18. So x squared would have to be 2 times that and divided by 3, 12. So the x is going to be the square root of 12, that's 4 3's, 2 root 3, and taking the positive one, since by definition x is greater than 0. So something happens when x is 2/3, and the question says it should provide a maximum volume, but I'll just check that. I could make up a nature table with 2 root 3 and then see what happens before and afterwards for the area. Do that if you wish, pick a number before and after, or you can use the second derivative, because the second derivative will be quite neat. The first derivative gives this expression, so the second derivative will be differentiate it again. Constant disappears, and that's just going to be the 2 goes across and multiplies, making it negative 3x. Very simple. Because no calculations required, that means that that is always negative, because x is always positive. Negative 3 times a positive. And if the second derivative is negative, that means you've got a maximum value. So there's a quick little justification using the second derivative. So then, that means the maximum volume will be, since it's a prism, area base times height, it will be 60 times the area, will be 60 times the maximum area, which is found when x is 2 root 3. So just got that to work out now. Not let myself an awful lot of room here. So 60 times, now what is the area? It's given by this expression, or I could use that expression. So it's going to be 2 times this value of x. So it's going to be 4 root 3, bracket, 9 minus a quarter of, again, 2 root 3 squared, So 2 root 3 times 2 root 3 will be 4 times 3. So I've got 240 now in there. 240 root 3 times 9 minus, that's just 3 is 6, times 6, which eventually just gives me 6 times that. So that's going to be 24,21440 root 3, and I presume it's all in metres cubed for the exact value of the maximum volume. Or, if you wanted it as a decimal, but that's actually the better answer, then just pop into your calculator and you get 2494.153 to round off, metres cubed, to round off as you please.